parallel universes are no longer just a feature of a good sci-fi story. There are now some scientific theories that support the idea of parallel universes beyond our own. However, the multiverse theory remains one of the most controversial theories in science. Our universe is unimaginably big. Hundreds of billions, if not trillions, of galaxies spin through space, each containing billions or trillions of stars. Some researchers studying models of the universe speculate that the universe's diameter could be 7 billion light-years across. Others think it could be infinite. But is it all that's out there? Science fiction loves the idea of a parallel universe and the thought that we might be living just one of an infinite number of possible lives. Multiverses aren't reserved for Star Trek, Spider-Man and Doctor Who, though. Real scientific theory explores, and in some cases supports, the case for universes outside, parallel to, or distant from, but mirroring our own. The concept of the multiverse arises in a few areas of physics, but the most prominent example comes from something called inflation theory. Inflation theory describes a hypothetical event that occurred when our universe was very young, less than a second old. In an incredibly brief amount of time, the universe underwent a period of rapid expansion, inflating to become many orders of magnitude larger than its previous size, according to NASA. Inflation of our universe is thought to have ended about 14 billion years ago, said Heling Deng, a cosmologist at Arizona State University and an expert in multiverse theory. However, inflation does not end everywhere at the same time. It is possible that as inflation ends in some region, it continues in others. Inflation ended in our universe, there may have been other, much more distant regions where inflation continued, and continues even today. Individual universes can pinch off of larger inflating, expanding universes, creating an infinite sea of eternal inflation, filled with numerous individual universes. In this eternal inflation scenario, each universe would emerge with its own laws of physics, its own collection of particles, its own arrangement of forces and its own values of fundamental constants. This might explain why our universe has the properties it does, particularly the properties that are hard to explain with fundamental physics, such as dark matter or the cosmological constant. If there is a multiverse, then we would have random cosmological constants in different universes, and it is simply a coincidence that the one we have in our universe takes the value that we observed. Many scientists have tried to find more physical, hard evidence for the multiverse's existence. For example, if a neighboring universe happened to be close to ours long ago, it may have collided with our universe, creating a detectable imprint. That imprint could be in the form of distortions in the cosmic microwave background, the light left over from when the universe was a million times smaller than it is today, or in strange galaxy properties in the direction of the collision. But all of these types of searches have come up empty, so the multiverse remains hypothetical. The most mind-bending implication of the multiverse is the existence of doppelgangers. If there really are an infinity of universes but a finite number of ways to arrange particles in any individual universe, then the same patterns are bound to be repeated, eventually. That would mean that at some incredible, but finite, distance, there would be an exact copy of you watching an exact copy of video. And because there would be an infinite number of universes, there would be an infinite number of these exact scenarios all happening simultaneously, according to the Institute of Physics.